So this is a solution for the second exam. This is the first one. First one, most people did it right. So 4ZR is a common factor. So we need to multiply by the inside 3 terms. And then afterwards, some people are trying to factor something because this word simplifies here. Actually, we observe inside, we don't have like terms. So those 3 terms, you know, they are not like terms. We cannot combine them. So if we multiply by a common factor, they're still not like terms. If they're not like terms, we cannot simplify anything. So I guess many people was confused by this word simplify. Okay, I wouldn't put a simplify there. But anyway, sometimes it may be, you know, it can be simplified. But in this case, we just multiply 4ZR with the 3 terms inside the parentheses. So 4ZR times 5Z raised by 3R. 4 times 5, that's 20. Z times Z3. Z is Z raised by 1. So 1 plus 3. If we have multiplication of same base, we add the exponents. So Z to the 4th power. Then R squared, right? Because of R times R. The second one, we have 4 times 6, 24. Then we have Z times Z squared, becomes Z3. But we still have R there. So Z raised by 3R. Then plus the last one. So many people just read number 8 here, but we still have a ZR, right? So that's 8ZR. And that's it. We cannot simplify this. We cannot do anything else. Let's see 2. Factor completely. So first we observe these 2 terms have a common factor of 8. So whenever the terms have a common factor, we like to do that first. So after factor out, we have x cubed plus 8. Now x cubed plus 8 is a sum of 2 cubes because 8 is 2 raised by 3. So that becomes x plus 2 times first one square minus product those 2x, then plus 2 squared, which is 4. So now it's complete, you know, it's factored completely. So 3, we want to solve for this inequality. And we want to write in the interval notation and graph. So 3 things we need to do. And some of us forget to write in interval notation. Well, we have 3 sides, right? We have the left-hand side. We have left-hand side. We have expression in the middle. We have a number on the right. So what do? We subtract. So we focus on the middle side because we want to solve for x. We want to isolate x. So we subtract 1 on 3 sides. Minus 3 minus 1, that's minus 4. The middle, we just have 2x now. Well, 9 minus 1, that's 8. Then we divide by 2. Right? Negative 4 divided by 2, negative 2. 2x divided by 2, just 1x. Well, 8 divided by 2, get 4. Oh, hold on 1 second. I add the equal sign. There's no equal sign on the right-hand side. It's just less than. So interval notation means we want to write as from negative 2, the small number, which is negative 2, with the equal sign, we write as a bracket. Then up to positive 4, but not including 4, we write close parenthesis. Now mark on the, so graph it, we make a solid dot on negative 2. We make an open circle on 4. Now we connect those 2 to show, okay, those are the solutions between those 2 numbers, including negative 2, but not including 4. Well, let's see, 4. 4, similarly, we have 3 sides. We have the left-hand side. We have the left-hand side. We have something in the middle. We have the right-hand side. The difference from before is we have two variables. So we have x and y. That means our graph will survive in two-dimensional plane. So how do we do this? We want to solve for y. Remember that, right? We can pull this on the side, rewrite as this. Because the y term is negative, so we can write as 63x minus 6y less than or equal to x plus 2y, right? Then we write the other side as 63x minus 6y less than negative 18. So we want to solve for those two inequalities. Remember, we're solving for y. So I would move negative 6y to the other side, become positive 6y. Right? Then I like to move x to the other side. It becomes a negative x. So now 63x minus x, that's 62x. Less than or equal to 2y plus 6y, that's ay. Now I divide by a on both sides. Right? So y is greater than or equal to 62 divided by a. Let's divide by 2 first. So I get a 31 divided by 4. Right? 31 divided by 4, I can split as 28 plus 3 divided by 4. Right? X. Let me not forget about the x. So usually we write y first. So y is greater than or equal to, well, 28 divided by 4, that's 7. 3 divided by 4, 3/4, right? We can think as 7.75x, or just leave the number 31 over 4, x. Then now we need to graph the line. So how do we graph? We graph the line y equals to 7.75x. Well, if x is 0, we get the origin. So we get a 1 point here. If x is 1, we get 7/3, right? X is 1, we get 7/3. It's off the chat. Or maybe let's do, if we do half, a little bit difficult to have. It's a little bit off the chat. 7/3 is somewhere here. Then I can graph this one. So let's use this one to graph this straight line. So I connect this point with this point. Right? Then I want to make this line longer. Right. So that's this line. Because I have equal sign, because you see the y greater than or equal to, so I draw solid. Right, draw solid dot. Or actually, this one is also greater than, less than or equal to. Both sides have equal sign. You see this one. This one greater than or equal to, less than or equal to, both have an equal sign. So I draw solid line. So that's the first one. Then I look this sign. It's greater than means it's above, right? Means above, means all those. So I graph this one with the vertical lines. I graph with the vertical lines, all those. Then let's see the second one. The second one, I have 63x minus 6y less than or equal to negative 18. Yeah, I move to the other side. I move negative 6y to the other side. It becomes positive 6y greater than or equal to 63x plus 18, because I move negative 18 to the other side, become plus. Now I want to divide everybody by 6, because I'm solving for y. 63 divided by 6, well, let's simplify it. So let's simplify with 3. So I get 21, 3, I get 2. So I have 21 divided by 2x plus 18 divided by 6, that's 3. Less than or equal to 6y divided by 6, that's just 1y. So usually we write as y greater than or equal to, well, 21 divided by 2 is 10.5, right? 10.5x plus 3. So same thing, we're gonna get 2 points. If x is 0, we get a y as 3, because we want to graph y equals to 10.5x plus 3. If x is, let's say, -1, okay? If x is a -1, we get a negative 10.5 plus 3, so we get a negative 7.5. Why take a negative? Otherwise, if I take a positive 1, I get a 10.5 plus 3, 13.5 off my chat. So I take -1, I get negative 10.5 plus 3, that's negative 7.5. So if I have negative, so let's graph those 2 points. Let me graph with red color. 0, 3, I have this point. Then I have -1, negative 7.5 somewhere here. Now let's graph it. And connecting those 2 dots. Then this one maybe go a little bit up. Right. Well, now let's look at the sign. The sign is also greater than or equal to y greater than or equal to. That means on the right-hand side of this red line, that means all this. So we graph with horizontal lines. Right. So where is the intersection? You see, all those are the intersections of those two. Yeah. So that's it, the intersection of those two. Okay, now let's see 5. 5, we came back to 1 dimension again. So, but the key word is or. So we get a solution of the first one, we get a solution of the second one, then we uni those two. So or means uni, we uni those two solutions. Well, let's solve for the first one. The first one we have, maybe we move 9x to the other side becomes negative. So we have 11x minus 9x. And then we move 6 to the other side becomes negative. So the sign stays, right? We have 4 minus 6. 4 minus 6 is negative 2, greater than or equal to 11x minus 9x, 2x. We divide by 2 on both sides, so it's x less than or equal to -1. But usually we write the variables first. We write x greater than or equal to -1. We say switch x to the other side, and the big mouth is still towards x. So this reads as x greater than or equal to -1. So this also reads x greater than or equal to -1. So I have this set of solution. If I want to use, because I'm asked to use interval notation. So I want to write in interval notation. That means bracket, because I have equal sign in the inequality, up to positive infinity. For this second part, I move 3x to the other side. So I have 11x minus 3x. Only greater than, no equal sign. I have -4. Well, move this -4 to the other side, become positive. -4 plus 4 is 0. 11x minus 3x, 8x. Divided by 8 on both sides, so that becomes x greater than 0. Or what's the solution for this? 0 up to positive infinity, right? Now, union those two. Now let's graph. So from -1, oh, hold on a second. I made a mistake. Why I change this one to be x greater than? This is x less than. You see 2x less than or equal to -2. Somehow, yeah, I made a mistake. This is less than or equal to. This is less than or equal to. So this is not right. So this is bracket, not bracket, open parentheses, because x is less than or equal to -1. Negative infinity up to -1. That's this solution. So we union those two solutions because it's or. So our interval solution would be negative infinity up to -1, union 0 up to past infinity. How do we show on the graph? Well, -1, oh, -1 is bracket. -1 is bracket because we have a less than or equal to. -1 is with bracket, but 0 does not. So we make a solid dot above -1. It goes this way because it's less than, right? That means from negative infinity up to -1. Then the other side starting from 0, but not including 0. So make an open circle on 0 up to past infinity. This is 6. 6, we're dealing with inequality signs. We see these two inequality signs here, right? This inside means this is inequality. Our goal first is to single out this inequality part. So what do? We want to get rid of this 5. And some of us did 5 minus 8. We cannot do that because this a is this is one term. Because it's a multiplied by this absolute inequality. So we cannot do 5 minus 8. What we can do is we move 5 to the other side. Becomes negative, right? Becomes negative. Then we have negative a times absolute value of 4x minus 1 equals to negative 19 minus 5, negative 24. You see negative a multiplied by this absolute value expression. So now we can divide both sides by negative 8 to get rid of the negative 8. Then we have absolute value of 4x minus 1 equals to 3. Negative 24 divided by negative 8, positive 3. So now we're in an ideal situation. So this is the first step. We always want to single out the absolute value expression. Now we're dividing into two cases, right? The first case is 4x minus 1 is positive, or minus 1 is positive 3. Second one is 4x minus 1 is negative 3 because absolute value of negative 3 become positive 3. Solve this one, we got a 4x equals 3 plus 1 equals 4, x equals 1. Second case, move negative 1 to the other side, where negative 3 plus 1 becomes negative 2. So x equals to negative 2 over 4. Simplify, negative half. So we have two solutions, 1 and negative half. Now let's see 7. Absolute value of inequality. Well, if sometimes we get confused, this less than tells us the graph is this. Right? Let's see, this is 5, 0 somewhere here. This is 5. This is negative 5. Remember, absolute value means we're only considering the distance. So the value is less than 5 has to be in the middle of those two. Has to be those ones. This is a 3x plus 8, right? 3x plus 8. So what do? We can write as this, 3x plus 8 less than 5. but greater than -5. Right inside these values, think about this: -4, -3, -2, -1, 1, 2, 3, 4, 5, right? Those values are less than 5, but bigger than -5. Then we minus 8, for 3 sides. To get a -13 less than 3x less than -3. Then we divide everything by 3, get -13 divided by 3 less than x less than -1. And we want to represent it with the interval notation. So that goes from -13 over 3 up to -1. And that's it. Okay, let's see number 8. We want to factor by grouping. Because we have 4 terms, we want to group them 2 by 2. The common factor of those first 2 is y. So factor y of x squared plus 3. The second group have common factor of 6. So we have x squared plus 3. Because 3 times 6 equals 18. Now the two groups have a common factor of x squared plus 3. So factor out x squared plus 3. What's left in the first group? Y. What's left in the second group? 6. So now we're in the factored form. Now we want to grab this inequality. 2 variables, right? Y less than x plus 1. We need 2 points because first we want to graph 2 steps. First, we want to graph y equals to x plus 1 with dotted line, right? Because this has no equal sign, the inequality. The inequality has no equal sign, so graph with a dot. Well, if x is 0, 0 plus 1, y is 1. If x is 1, 1 plus 1, y is 2. If x is 2, 2 plus 1, x is 3. So 3 points, good enough to graph. We have this point. Well, 1, 2, this point. We have 2, 3, we have this point. Right? And that's it. Let's graph with a straight line. We're gonna let this keep going. Now the sign says less than. Less than will drop below the line. Oh, with dotted line, actually. Let me erase. So it's not like that. I have to draw dotted line. Okay, I won't be able to draw, so I'm gonna draw with my hand. Because we have to draw dotted line, because no equal sign in the inequality. Just imagine this is a perfect straight line, right? I won't be able to do that. So now it's less than, so shade it below, right? All this. Okay, that's 9. Now let's see, 10. Again, factor completely. First, we're looking for common factors among those 3, which is t raised by 5. So factor out t raised by 5. Then t raised by 7 becomes t squared inside, and plus 4t minus 5, right? T squared times t raised by 5 still get t raised by 7. 4t times t to the 5th, still 4t to the 6th. -5 times t raised by 5, still -5t raised by 5. Now we have a polynomial here, or trinomial. We're thinking, can I factor as 2 binomials? Well, -5, the 2 factors of -5 adds up to be +4. Well, yes, +5 and -1. So factor as t plus 5 and t minus 1. But we cannot forget about t raised by 5. T raised by 5 is part of it. Let's see 11. 11, we want to subtract those two binomials, these two polynomials. So check the degree. We have 6x cubed, but this one has no x cubed. Then we have 5x squared minus a squared. Right? Then the first one have no x term, but the second one has minus -9. Well, let's do by order. So first, 6x cubed has no common factors. So just write down 6x cubed. Then 5x squared minus 8x squared, that's -3x squared. The x term will have minus -9, that becomes plus 9x. The constant will have a minus 1, that becomes 7. And that's it. We don't have to do anything else. So I have 4 terms, polynomial degree 3. Now let's see 12. Solve inequality and write the solution set in the interval notation. Again, this one variable, but we see distribution, right? We see 5 is the common factor of the 2 terms inside the parentheses. So 5 times 12, we get 60x. Then plus 5 times 2, that's 10. Less than or equal to 9 minus 3x. Now we want to move -3x to the other side, become positive. 60x plus 3x, 63x. Less than or equal to, well, this is positive 10. When we move to the other side, it becomes 9 minus 10, which is just -1. So 63x less than or equal to -1 divided by 63 on both sides. X less than or equal to 1/63. And use interval notation, less than or equal to, we're starting from -infinity because it goes to the left-hand side. Well, who's waiting on the left-hand side of the number 9? -infinity. Including -1/63, we use bracket. Well, 13 factor completely again. We checked. We see we have common factors, right? Common factor is 3. So let's factor out 3. Then we have 3x squared minus 8x plus 4. Now no more common factors because 3 is a prime number. But we're thinking, okay, how do I manage the factors of 3 and the factors of 4 to get -8? Well, we see we can change positive 4 to be -2 times -2. So we can factor this as 3x minus 2 times x minus 2. See -2, positive 4. Right? -2x plus -6x, that's -8x. So that's a solution. 3 times 3x minus 2 times x minus 2. Let's see 14. 14, rarely people made it right. So we want to get rid of the -4, right? The denominator. So we would multiply -4 on both sides. I think maybe 1 or 2 students did it right. Remember what happens when we multiply by a negative number? We switch the sign, right? So we get 3x minus 2 greater than or equal to -4. Because this, when we multiply -4 divided by -4 becomes 1. But the right-hand side, we still have 1 times -4, which is -4. The left-hand side, we just left with 3x minus 2. Now we just move -2 to the other side. It becomes -4 plus 2, which is -2. Divided by 3 on both sides, we get x greater than or equal to -2/3. Interval notation again, greater than, we're starting from -2/3. But who's waiting on the right-hand side of the number 9? Positive infinity. Now let's see 15. We want to solve this quadratic equation. So first, we move negative 40 to the other side. It become positive number. We want to make the right-hand side to be 0. Now we think about two factors of 40 adds up to be 14. That's obvious. 10 and 4, right? And both be negative. Multiply negative 10 with negative 4, we get a positive 40. Plus negative 10 with negative 4, we get negative 14, the middle term. So this means x minus 10 can be 0, or x minus 4 can be 0. So x has two solutions, 10 and 4. Last two questions, 16 and 17. 16 factor completely. So first we check common factors of 32 and 18. 32 is 2 times 16. 18 is 2 times 9. So the only common factor is 2 times 16m squared plus 9n squared. So we haven't studied complex number yet. If we studied a complex number, I'm not sure if our coordinator moved this question from pre-calculus to here. That becomes 4m squared plus 3n squared. Now, if we knew, so for us, it's only this. This is good enough for us because we're in the real number world. But in the future, or for pre-calculus students, this can be factored as imaginary numbers. So we would have 4m plus 3ni. I think some people did it. Times 4m minus 3ni. Because in complex number system, especially with the imaginary part, and we can factor the sum of two squares. But in real numbers, we can only factor the difference of two squares. So for us, this, okay, in the future, we do this. Last question, 17. The product, right? Product means multiplying. Two consecutive page numbers is this. Find the page numbers. Well, let's call one of the pages X, right? If we call the first page X, then consecutive means continuous, the next number, which is X plus 1. When we multiply those two, we get 182. It's a quadratic equation, right? X times X, X squared. X times 1, just X. Move 182 to the other side. Now this can be simplified, right? 13 times 14. If you don't see how simplified, so you can do this. You want to find the factors of 182. First, you see this can be divided by 2. 2 times 9, 18. 2 times 1, 2. Right? Then 91 can be divided by 7. 7 times 3. Right? No. Right, 7 times 3, 21. Well, first do 1, right? 1 times 7, 7. Then 9 minus 7, 20, 21. 21, 3 times 7 will be 21. So it will be 13. So multiply those two, is 14. So the two factors, 14 and 13. So we can factor this as x plus 14 and x minus 13. Right? 14 plus minus 13, that just passed 1x here. That means x plus 14 can be 0. X minus 13 can be 0. Well, x minus 13, x equals 13. X plus 14 equals 0, x equals negative 14. But we never count page numbers as negative numbers. We reject this. So x equals 13. If x equals 13, x plus 1, the next page is 13 plus 1 is 14. So to answer the questions, the page numbers are 13 and 14. Okay, so this finishes the solution set for exam 2.